Yeah, and they're actually, it's a matching section. Okay?
That's new.
Get what? We didn't get a study guide.
Oh my god.
Mr. Pettyjohn, do you have the study guide for this unit?
No.
You
No, I
want the
didn't.
study guide.
Hey, I'll make you one. We're making one right now. Let's call this the study guide. Okay? Because look, it's like everything that I was given for this is right here. Okay?
Yeah.
Percent yield.
You're on TV.
You need a stand, Shimura.
What do you mean I need to
So you can take notes. You need to put it on something. Like, you need some water.
Oh, you said a stand.
Okay.
I thought you meant I need
Okay,
a
so let's talk about each one of these things, right? Let's start with actual yield versus theoretical yield. Which one do you think is always larger?
The actual theoretical.
No, because the actual yield is always a percentage of the theoretical yield. The theoretical yield is like 100%, right? If you assume 100% actual yield, it means the actual yield and the theoretical yield would be exactly the same thing. What I mean by that is like, let's pretend if my actual yield, let's just pretend that it was 20 grams. But what if the theoretical yield was like 40 grams?
This is the definition.
So I know, but I'm just explaining. Okay, so in the actual yield, and then the theoretical yield, the actual yield is what actually happens in the experiment versus the theoretical yield is what would be possible if you had 100% of that experiment react. Okay? Now how would I then get percent yield from those two numbers?
Divide them. So
Yes,
20
you would
over the-
divide the actual yield by the theoretical yield. And then you would times it by 100. Right? So literally, you could actually do actual yield divide by theoretical yield times it by 100. Okay? And that would always give you the percent yield. Okay? Now, on one of the questions on the test, I actually give you the actual yield and I give you the theoretical yield, and you just have to know what to do with them.
Wait, so for the matching, there's like definitions of these words?
For the matching
Are you gonna
numbers.
give us those definitions?
Yeah. Okay, so in this situation, the percent yield would be like 50%, right?
Yeah.
Because 20 out of 40.
Uh-huh.
Okay, just to give you that example. Now, the actual yield is from experimental data. So the yield, okay, the yield,
So is the
From
percent yield gonna
an-
be bigger or smaller than?
the percent will always be below 100%. Because you always take the smaller number divided by the bigger number. So you always have to take the actual yield, it'll always be smaller than the theoretical yield. Okay, so the yield from an actual experiment. It's the actual data. Like, for instance, if we were to mass the silver, okay, yesterday I found a bunch of silver, right? I collected a bunch of silver out of some people's experiments. And I actually, what if I forgot to mass the copper? If I was like, oh crap, I didn't do the mass of the copper. Do you think I could still find the mass of the copper? By the experimental data of the silver, right? I could mass the silver, I could drive the water off, mass the silver, do a little stoichiometry, figure out the moles of copper that must have reacted, and then I would actually be able to figure out the mass of the copper that went into solution. And then you could add that to the copper that was left over, and you would know the original mass of the copper, okay? So the actual data is what tells you, you know, the like real thing that happens, while the theoretical yield is what's possible. It's the amount that is possible if 100% reacted. Okay, let me ask you this. What if I say, if you react 32 grams of oxygen with So if I were to do a stoichiometry question, like 32 grams of O2, first thing you do is divide 32 by 32 because that's the molar mass of O2. So I would know that I would have 1 mole of O2, right? And if I did a balanced chemical equation, I could actually say like CH4 plus O2 yields CO2 plus H2O. And I would know then that I would need 2 of these and 2 of those, okay? So if I know that I have 2 moles up here, I only have 1 mole down here. So doesn't that mean that I only have half of that amount? So shouldn't then I only produce half of this amount? Like if I were to say like 1 mole of O2, if I wanted to change my mole of O2 to moles of CO2, because that's what I really care about, then wouldn't I actually do it by 1 over 2? Because there's 1 CO2 for every 2 O2s. So what's 1/2 of 1 mole? Wouldn't it be 0.5 moles of CO2? And I know that CO2's molar mass is 44 grams per mole. And half of that number is actually 22 grams, right? So if I know that there's, my theoretical yield is 22 grams, right? Well, what if I do this experiment and I only get like 12 grams or something like that, or 11 grams? Let's pretend my actual yield was 11 grams. Well, my theoretical yield is 22 grams, because I could take 0.5 moles of CO2 times the molar mass of CO2, which is 44 grams per mole. And that's 22 grams of CO2 that I can theoretically produce, okay? Now, if I want to figure out, like, what's my actual yield, you would have to run an experiment, and then you would actually have to figure out exactly how much CO2 you produce.
So
Let's
that's how
pretend.
you find theoretical yield?
Yeah, like what we've been doing is theoretical, okay? But if they ever ask you for percent yield, and they give you an actual yield, you still have to figure out the theoretical yield, because you have to take the actual yield divided by the number that you figure out. You see what I mean? That's why you guys stumbled over that one question on that 6-point quiz, where it was asking for the percent yield. They're like, how do you figure out the percent yield? You still have to figure out the theoretical yield. And then you take the number that they gave you, divided by the number that was possible, and that gives you your actual.
So you're never gonna have to find
your-
the actual yield on the test.
I don't think I give you the actual yield every time.
Okay.
Because the only way to get actual data would be like, do it, and I have to give you the actual yield. I doubt they're gonna be like, give you the theoretical yield and give you a percent and be like, what was the actual yield? And then you would just take that as a decimal and times it by the theoretical yield. You could technically do that, but I'm not gonna do that because that's dumb. Okay, so number 22, okay? Oh, I'm sorry, number 22 grams of CO2, right? What if the actual yield, again, what if the actual yield is equal to 11 grams of CO2? Then isn't there 50% yield? Like if I wanted to know, like percent yield, my actual yield is 11. My theoretical is 22. 11 out of 22 is 50%, right? So it's a 50% yield, right? You guys understand? Like that's like pretty much like the problem is the one thing, but like the interpretation of like what to do with the problem is another thing. Okay, so excess and limiting. These two are related, right? Which one determines the actual theoretical yield? The limiting reactant, the thing that runs out, right? So like, remember that one example that guy gave you about bologna and bologna sandwiches?
Yeah.
You need 2 pieces of bread and 1 piece of bologna to make a bologna sandwich. If I have 15 slices of bread, and I have 7 pieces of bologna, I don't know. How many bologna sandwiches can I make? You can still only make 7. So what's my excess?
Bread.
Yeah, and how many do I have left over? Because I need 2
One
per
bread.
sandwich. I only have 1 random slice of bread. You're not gonna make, with an odd number, you're not gonna make a good number of sandwiches anyway, right?
Hold it.
But what if I had the same amount? 7 and 7.
Then the bologna is the one that leaves
You have
over.
one extra slice of bread.
Yeah, because I can only know.
3 sandwiches.
Exactly, because you can only make 3 sandwiches, because 2 per sandwich means I can make 3 sandwiches, right? So I'm gonna use 6 slices of bread,
But then there's excess
and
for
I'm only
both.
gonna use how many bolognas?
3.
Well, that's kind of stupid, I have to use
Yeah.
a number, yeah. Okay, so I can make 4 sandwiches. And I can use 4 pieces of, so I would actually have, 4 sandwiches, 4 slices of bologna, right? So you would actually end up having like 3 slices of bologna left over, right? The whole purpose is the thing that runs out first is always the limiting reactant. It always dictates how many of a product you can make, right? So in a question like this, is there a limiting reactant, or does it just assume that you have unlimited the other one?
Unlimited.
Yeah, so what do you have to have for it to be a limiting reactant? What do you have to be given?
The limiting the
2 what at the beginning? You have to be given 2
grams?
2 amounts of 2 different things. So I could very easily, with these numbers, change this, okay? Can I do that with you guys? Can I change this into a limiting reactant problem? Because there is one question, okay? There is one question that you have to prove that you know what these are.
Wait, so what did you just do with the slices of bread?
It was an example of that.
Of
It was an
limiting
example
or
of limiting
excess?
both, because one runs out first, and then the excess would be the thing that is left over.
Okay.
So like, let's say that I did like, okay, I'll do it, here you go. So here is a piece of bread, right? 2 bread plus 1 slice of meat yields 1 sandwich, right? So if I did that, then isn't it true that if I had like 12 slices of bread and 4 slices of meat, how many sandwiches can I make? I can only make 4, which this is my limiting reactant. That's my excess reactant because I'm gonna have some left over. There'll be some in excess, right? So like right here, I'm gonna use all 4, right? Don't I have twice the bread that I do meat? So how many slices of bread do I use? Notice it's the same ratio. 1 to 2 is the same thing as saying 4 to 8. Now I'm gonna have 4 left over, 4 slices left over, right? So if I had 2 more pieces of bologna, cool, but I don't. Okay, so 8 to 4, and then over here, can't I make 4 sandwiches? 1, 1, 2, 4, 4, 8. Do you notice it's the same ratio? It always will be. Now, it's not always pretty like that, and we're not talking about sandwiches, we're talking about oxygen and carbon dioxide molecules. But still, the ratios, 1 to 2 to 1 to 2, are still pretty easy to deal with. Okay? Some of them aren't so easy. Some is like 3 to 5 to 8 to 2, or something weird. Depends on what balances the chemical.
Are you gonna show like how to do it in the form of a problem?
Yes, like right now.
Yeah.
Okay, so like, I'm gonna change it all, okay? So if I react 32 grams, let's just change it to like, I don't know, like 320. With how many grams of CH4? I don't know, like 160. Okay, so if I have hey, what's 6 times 16? 86.
96.
Nuh-uh.
32 times
It has
4.
a 6 at the end.
Oh yeah,
60.
you're right. 96.
Wait.
Yeah, I know that. Stop
Yeah.
playing.
It's on video.
Yeah.
Math. Alright. Alright, anyway, so 96. I was just challenging you. Alright, so 96 CH4.
Okay.
How many grams of CO2 can be produced? So you can still make, you can still make a theoretical yield of CO2, but the first thing you have to determine is which one's limiting, and then you do the same thing. You just determine the limiting reactant and handle the problem the same way you would. You ignore the excess until later, in which I'll ask you like how much excess is left over. But first things first, we have to even determine the limiting to do all of that. So what thing runs out first? Well, it's easy to look at and be like, I don't know, maybe this
I
one,
think
because
I'm
it's
gonna
less.
post it on YouTube.
You can't compare grams. You have to put it into moles, okay? because that's just the way, you have to. It always is molar ratios, like 1 mole, 2 mole, 1 mole, 2 mole. Okay?
I think
Hey,
I'm
if
gonna
1
post
gram of
this
this
on
plus
YouTube,
2 grams
so-
of that, is it really gonna yield 1 gram of this and 2 grams of that? No,
No.
it
I think
never
I'm gonna
works,
post this
because
on
everything
YouTube.
has a different mass. That's like saying that,
Oh.
does this marker plus this eraser yield this thing here and this thing here? Like, no, like they all have different masses. However, the number dozen means a number that we always know means 12, right? Just like the number mole means a certain amount of atoms. Okay, so it always, it means the same thing for no matter what you're talking about, is what I'm saying. So if we can convert to moles, like for instance, if I know the molar mass of O2, which is, we just did it, the molar mass,
32.
32 grams per mole, and the molar mass of CO2,
40.
and if we want to be crazy, we could do H2O is 18 grams per mole. CH4 is 16 grams per mole.
44.
This is 44 grams per mole. So the first things first, we need to actually calculate moles. Like we have to take 320 grams of O2 and divide by 32 grams per mole, and we'll actually get 10 moles of O2. Now, what do I get for CH4? Well, I have 96 grams of CH4 divided by the molar mass of 16 grams. And what's that equal to? That's what I said. That's what I asked. 6. Don't treat it like your bologna sandwiches.
You're going
Yeah, treat it
fast.
like. Am I going too fast?
Yes.
I'm posting this on YouTube for everyone. So.
YouTube.
Hey, you too.
Can you like put a comment on his Ed speed page with like your
I'll. No. What? I'll
Hey,
just come back.
75%
YouTube
speed.
Yeah, but like it's not. Doesn't matter.
Yeah. No, you're on pause.
25%. I'm on pause. Go me to pause.
My hands
Don't I need 2 slices of bread for every 1 thing of bologna? Well, check this out. I need 2 O2s for every 1 CH4. So do I have 2 for every 1? If I have 10 O2s, then don't I need 5 CH4s?
I don't know.
Do I have 5 CH4s? Yeah, I have more than 5. So isn't that my excess, and this one is what limits it? Because to react with 6 moles, don't I need 12 moles of oxygen? But I don't have 12 moles of oxygen. I have only 10 moles. So do you see what I mean? So the theoretical yield would be based on what runs out first.
Can you go again?
Yeah, no problem. Okay, and I know this is like,
Slower.
okay. If I have 10 moles here,
Uh-huh.
and I have 6 moles here,
Yeah.
you determine what runs out first based on the actual ratio of what reacts. I have 1 for every 2, and it will always follow that ratio. So doesn't that mean that I need twice as much oxygen as I do CH4 to react completely?
Neither of those is CH4. Oh.
Okay? So 10 moles of O2, don't I need only 5 to react?
Why?
Because there's 2 for every 1.
Yeah.
But I have 6. So don't I have an extra mole of CH4 that is not going to be able to react because I don't have enough O2?
So that's
We
limiting.
know that this is our limiting.
And the other one's
Is going to be excess. And we know how much excess just based on what I said, right? We know there's 1 mole, which we know will have 16 grams of CH4 left over if all of it even reacted. Okay? So now you ignore that. Wait, how? Do you want to know an easier way?
Sure.
Super easy way. Okay, I know you understand what I just did right now, but this is the way that is fail-proof. If you take the moles, okay, if you take the moles that you have for each one, and you divide by the original coefficient, you get a number. What do I get by 10 divided by 2?
5.
What do I get by 6 divided by 1? Which number's smaller?
That one.
That's why that's your limiting reactant. It will always give you which one is the limiting reactant if you do that. You need to be careful to put the right coefficients in there. Okay? You see what I mean? If you do that step every time, it'll tell you which one's right. Yeah,
I get everything besides where you got 96 at.
I gave it to
It's
you.
just in the problem.
It's in it. I gave you two masses.
Was that there before?
Yeah,
Yeah.
no.
Oh, I didn't see it.
Can you give us, the exact definition?
Yeah, can you give us definition?
Hold on, let me finish the problem. We're not even close to the finishing part. This is just to determine what problem to do.
We're not even close to that.
You just plug it in, okay? But what do I actually care about? The only thing I care about is the grams of CO2. So if you're like one of those people that you want to do the minimum, like me, I only care about that, right? I only care about that. I would never do extra work. I would always care about this. Now, if you want to like be able to check your answer, I could probably show you how to, but it'll take too much
So
time
what
for
is the
everybody to
answer to
bend over.
that question?
Okay, so you will take 10 moles of O2, and we want to convert it into moles of CO2, right? You have to go from moles, grams, to moles of like the thing you're trying to figure out, back to grams of the thing you're trying to figure out. So 10 moles of O2, how many moles of CO2 do I have for every mole of O2? Look at your original problem. You notice that I have 1 for every 2? So don't I then times that by 1 CO2 for every 2 O2? And I would know that that's 5 moles of CO2. Okay, because it's like half of 10, right? Now that you convert it to moles, isn't it easy to convert back to mass again? Because you know the molar mass of CO2. So I just multiply my 5 moles of CO2 times 44 grams per mole. And that's equal to something. 220? Okay. Now what if I asked you, how much excess is left over? Well, O2 is gone, right? It's the limiting reactant. But what about the thing that you had extra of? Okay?
Did we have extra?
You had extra CH4. Because not all the CH4 reacted. Isn't it true that only 5 moles of CH4 reacted? Still, yeah, because it has to follow that ratio, right? So don't you then have 1 mole left over? Because we have 6 moles of CH4, but only 5 moles could actually react. So what you could do is you would just take your excess is 1 mole of CH4 in excess. And you could take that times the molar mass of CH4, which is 16 grams per mole, which is 16 grams of CH4 in excess. If I wanted to ask you how much is in excess, right? Yeah, there will be like one very big problem just like this. It's not multiple choice, it's on the back of your Scantron. One problem, it'll be almost identical.
Mine. Oh.
Now how did I get that?
That was one problem.
This is not even done with one problem. Because what I'm gonna say, I know, and that's the thing, it's like,
Can you give us the word definitions of these two?
hold on.
Okay.
Okay, percent yield. Okay, I might ask you, at the end of all of this, isn't that my theoretical yield is right here? That's my theoretical yield. What if I said, though, that only 200 grams of CO2 were produced? Then don't I just take 200 divided by 220 times 100, and that gives me my percent yield, right? So all of those things are going to be built into one problem.
One problem. How
The
many?
percent yield would be
Wait.
like as if I had 200 grams. If I gave you an actual yield, if I said in the problem that my actual yield is equal to 200 grams of
I don't even know
CO2.
what's happening.
Wait, whatever you give us.
Okay. Yeah, you would just take 200 and divide by the theoretical yield. Okay? Divide
Okay, so
by,
if we were just looking for theoretical yield, then 220 would be our final answer.
yes.
so
And
what's
that's
the
always
16?
really,
So
That's your
if we're
excess.
the
looking
16
for
grams is
percent
the
yield,
excess because you determine theoretical yield based on the limiting reactant. The excess reactant, not all of it is able to react. It can still only react in the same ratio. So see how that's like 1 to 2?
right.
So compared to 10, only half of it can actually react, right? Do you see how 10 needs to be compared to like a 5? Is like 5 to 10 is the same as like 1 to 2, right?
Okay.
So only 5 of the 6 moles actually react. 1 mole is left over. So that's why I got 1 mole. You could subtract, the 5 that reacted, and then you would know that its molar mass is 16 grams per mole. So 16 grams would be left over
If 2
So are you
moles
gonna
were
give us
left,
the actual
it would be
yield? Like
32.
if there was a problem exactly like this?
I'll always give you the actual. There's no way for me not to give you the actual yield because you would have to do an experiment to get the actual yield.
Okay, then I'm good.
So if I gave you the actual yield, you would divide by the theoretical yield of what you determined. And then you would times it by 100, and that's equal to your percent yield.
90.9.
Is it 90?
0.91, if you round to that.
That's your percent.
Wait, Mr. President. So, this particular question, like the one that's on the board there, it's asking for the amount of grams. So the answer to this one would be 220.
It would be 220. But I would ask you other questions. I'm just trying to show you like how I could ask you those other questions. Go. Yep.
Can we do one more problem?
Yes, and actually before I do that, because there's been requests on filling out those, things. So excess reactant versus limiting reactant. The reactant that is used up in a reaction.
Hang on.
It determines
No. Today?
There's just like an extra.
okay. Determines the theoretical yield. If you had 12 pieces of bread and 4 pieces of meat, how many sandwiches could you theoretically make? You could make 4. But what if I got real lazy? My actual yield would be 75%. Or my percent yield would be 75% of my because your actual yield would be less than your actual
The
theoretical
answer,
yield.
don't
What was
know.
possible, right? Yeah.
Would you ever make a problem to where we gotta find the actual and you give us the theoretical?
No, I don't do stuff like that. Okay, so theoretically, excess reactant is the reactant that, is in excess? I don't know. It will not all be used.
Are these
It
gonna
will
be the
not all
definitions
be
on the
used.
test?
Is this gonna be, like, is that how it's, like, close to being worded on the test?
Or is it gonna be like an internet, like Google?
Yeah,
like,
because
definition?
if these definitions aren't on the test,
Test.
I don't want
Yeah.
them.
Like, are these basically what's gonna be on the test?
There's a matching section, it's
Those
like.
are the definitions that are
Or
like.
did
on
you-
the
They're
That
not
word
word
for word
for
is gonna be
word,
the
they're
same.
like, that's like what they mean now, that's like what they are.
But if on the test you have like the Google version of the things, then we have to like figure out what it is, and that's too much.
Honestly, whatever.
Like if on the
If the
test,
definitions are more complex.
Ratio is
Oh my god,
The-
I'll tell you
I don't
what.
root for this.
ratio
Go to the bag.
You have 10 minutes.
in moles that result in a balanced balanced chemical equations are the main recipe, like right here. Mole ratio, 1 to 2 to 1 to 2. That is the main ratio. It's a whole number ratio that balances a chemical equation. And what law do you think it actually abides by? The law of conservation of,
Energy.
not energy, but mass.
Yep.
Because each particle, what's the molar mass of O2?
32.
Right? What's the molar mass of CH4? 16, right? What's the molar mass of CO2? 44. What's the molar mass of 18? So check this out. On the left-hand side, 1 times 16 is 16. 2 times 32 is 64. 1 times 44 is 44. 2 times 18 is what?
I'm not following. 16.
So don't they add up?
32? Nope.
They will
hang on.
literally add up to every atom. Okay? They will always add up, and that's why stoichiometry always
wait, why?
works.
Wait, okay,
That's
question.
why you have to use mole ratios and not mass ratios. Yeah,
Are we gonna need to know that?
that is stoichiometry. That is literally the concept of everything. This is mole ratios. The mole ratios abide by the law of conservation of mass. It's what makes balanced chemical reactions. That's like what makes it work. Yeah.
Oh, you almost get paid for this section on top.
Essentially.
One more big one or whatever.
One more big one.
Pettyjohn, before you
Should I film the second question too?
the 10
No?
multiple 2 times the 1 over 2.
First one is
Yeah.
just.
You know,
That was
and then
probably
we
like
found 11